Okay, so we're back with hour 2. So we've got one unit test written, which passes. Right? So if we call set text with 1, our unit test expects that whatever's currently displayed now has a 1 stuck on the end of it. And we run that test. It passes. We can check our code coverage here. It's not going to be very much. Oh, interesting. Okay. We're actually at 80%. We want to check in here. So in our calculator and in form 1. So this is cool. It says our set text method is now 100% covered. One sec, Stuart, come to you. If I click this button that says show code coverage coloring beside the red X here, and go back to my form 1, this will show us, so anything in blue, so here's our method, so all one line of code in this method, it says is fully covered in blue. So if it's red, that means it's not covered by a unit test. If it's yellow, it means it's partly but not completely covered. Okay, so I went to test, analyze code coverage, and picked all tests. I am on enterprise, so you may not have it in community.
Wait.
So that was under test and analyze code coverage.
Oh, you go to test Windows and then code coverage.
Thank you. Test Windows, code coverage results. There's one super annoying thing about this window, though, which has been driving me crazy all week, which is if we write new unit tests, there's no refresh button. You have to click test and analyze and then expand it all every time. I have no idea why they didn't create a refresh button that just says, okay, run it again. So we can see what's covered and what's not covered. So obviously now our set text method is covered, which is good. So we shouldn't need any other unit tests because there's really only one possible thing that can happen here. And our test covers it. So we want to start testing the actual math operations. So we've got an add button, subtract, multiply, divide. And all of these are untested, right? When I look at my code, it's red. When I look at my code coverage here, for example, the add button add, it says there's 7 blocks of code and you haven't unit tested it. We haven't unit tested any of them. So we want to start unit testing this method. So we should probably look at exactly how it works. So when the user clicks the add button, the first thing we're going to check is, did they type a number first? Is there a number in the display? Because if they just start the calculator and click the plus button, we don't want to do anything. So is there a number? So we're going to use try parse to make sure that there's a number being displayed. If there is, we're going to set our operator to the plus sign. We're going to call our calculate method, and we're going to pass in whatever number is being displayed. So if the user typed 34 and hit plus, we're going to send 34 to our calculate method. And then we want to clear out the text. Right? On a calculator, if we run it, you use any calculator. So I type 34. When I hit plus, my calculator needs to remember a couple of things. It needs to remember that I've typed in 34, and it needs to remember that I clicked the plus button. I didn't click one of the other buttons. What should happen to my display once I click the plus button? Pull up calculator on your phone or the calculator app on Windows. What happens when you click any one of those operators? Yeah, it clears out. So it remembers what was in there, but it wipes it out so we can then type a new number. Right? So when I hit plus, we can't throw that 34 in the garbage, and we can't throw the decision that I click plus in the garbage. We need to remember both of those things. So we want to test that when we click add, all of those things happen. That the number entered gets remembered, and that when we call calculate, that it knows what number is entered, and our calculate method is going to know that the operator is the plus. So we're going to write our second unit test. We'll create another test method. We'll call it add because it's testing our clicking add, and we'll say valid. We expect, so this is where we get the result we're expecting. So we go through the same process of arrange, act, assert. Set up the values we need, run the test, and evaluate the results. In our button, just like we did up above. Now this code is repetitive, so we have a simple way in a unit test later on where we can move this code into a separate place, so we only need to write it one time. We'll do that after we get this unit test working. So now let's set up a scenario. So our scenario is we already have a value of 10. I'm going to use this variable called current total, and I'll initialize it to 10. We'll imagine our user has already typed in, hit the 1 button and the 0 button. Then, afterwards, they hit the 2 button. So they want to add 10 and 2 together. We're going to set first input equal to false because we have 2 numbers. If we only had 1 number, we wouldn't be adding anything yet. We can't do an add until we have 2 numbers. So we're going to assume we have 2 numbers. We started out with 10, then the user hit plus, and then they typed in a 2. The last thing is we're going to set our operator to a plus sign. In effect, we're simulating in our test what would happen if a user did this. So we're kind of simulating this. 10, the plus, and then the 2. So this is what we want to test. So we're kind of writing a code version of that simulation. 1, 0, plus 2, and then equals. So our act we call our calculate button, or we call our calculate method. What value do we pass into our calculate button? The display says 2. So we started out with 10, they hit 2, then they hit equals. What value do we need to pass in here? Nope, that's what we're going to check for 12. So here's our current value. So they press the 2 button. Well, we're actually setting the operator here. We've got a variable for the operator. If we have 10 and the user types a 2 afterwards, we want to then add this number and this number together. So then, Stuart, 12 is what we're going to assert for. We're going to check that when we call this, the current total becomes 12. So we'll use R equal. So we expect to get 12. And we're going to check our current total. Show you where this comes from. So if we're adding, we take the new value and we add it to the current total. So then we want to inspect what the value of current total is after we do our calculation. So let's run this test. If we build so it says you got a new test here that we've never executed. So I'm going to say run any new tests, or you can run them all, it doesn't matter. So this test passes as well. If we start out with 10, we add 2, we expect our calculator is going to give us back 12. So we can kind of watch this happen if I debug it. So we call calculate, we pass in a 2. It's not our first input because we've already simulated that the user started out by typing 10. So now we're going to use a switch statement to evaluate what operator is it. Well, it's a plus sign. So our current total is 10 and our new value is 2. So we want to add our new value onto our current total. So we have 10. Our code goes in here. Current total is now, as Stuart suggested, is now 12. Our current total is now equal to 12, and we're checking that those two things are equal, that we are getting back the same value we expected to get. So our test passes. We'll just check where this takes us now in terms of our code coverage. How much did adding this second test improve things? So that's not bad. We went from 0% in our calculate method to 42% of it is covered by this one test now. So again, if we go and highlight and have a look, what do we see? So this section up at the top now where we're adding is blue because we've got a unit test that properly checks that code. So we've made some improvement just by writing one unit test. Now we did repeat ourselves in our arrange part. If we look at the two test methods, the first thing we do, create an instance of our form and reference our display. We've repeated that down here. We're going to need unit tests for subtract, multiply, and divide. In each case, we need to do this, right? We can't run our test if we can't talk to the form and can't access what's in the current display. So rather than repeating these lines of code over and over again, One of the other things that our unit tests have is there's a built-in initialize method. It's like a startup. So if we use that initialize method, anything we put in there happens before every unit test. So we don't have to do the same setup over and over again. So we're going to move these 2 lines of code into an initialization method instead. We don't even have to call that method. It will run automatically before every test. So I'm going to go up here, and instead of this being a test method, Visual Studio has this construct called test initialize. This runs automatically before each unit test. Remember, our tests, they're independent. They're unit tests, so one test doesn't depend on another. So I'm just going to move this code. I'll cut it out. And I'll paste it into my initialize method. And I can just remove those first 2 lines from both of my unit tests. So creating the form and reading what's in the button, those things now happen on our initialize method. So our unit test should still pass if I run them all. I'll just click run all. We didn't break anything. We've just removed the repeating lines of code. So this section is new, and we took out those 2 lines of creating the form and referencing our button from our unit tests. So we want to check here our subtraction, that it works, our multiplication, and our division. We'll want separate tests for each of those. So there was our add test. Let's write a similar test for subtract. The same. We only have to change 2 things from our add test to make it work on our subtract test. Which 2 lines are we going to change, and how would we change them? Anna? Yep, so we'll change the plus sign to a minus sign. Yep, that'll be change number 1. What'll be the second change? Jiva? Well, we want false to true here, you're saying? Well, we still want to keep this as false. This just means we only have 1 number, so we're not calculating yet, right? We can't do a calculation unless we have 2 numbers. So that's all this is used for. So we do have 2 numbers in this case, so we'll want to keep that one as false. Andy? Right. Right, so when we're asserting, rather than expecting a value of 12, we're going to expect a value of 8, right? Because we're going to this time subtract the second number from our first number. So we should be able to do this test. So my setup up here, my first 3 lines are the same. As Jen said, that one's going to change. and then our assert, as Andy said, that value is going to change. So it's almost entirely the same method.
Can you screencast it?
So in our arrange, again, we'll initialize, we'll kind of pretend our first number is 10. The user's typed in a 10 to start. Second number they entered was a 2. And again, we're saying our first input is false because we've been given 2 different numbers to work with. There's our first change. Our first 3 lines are the same, but our operator is different. We're not running the same type of operator. We're doing a different one. We're going to call calculate again. Now we're going to check our results. But as Andy said, rather than expecting 12, this time we expect 8. So we're going to compare and see whether the current total on the form is now equal to 8 if we subtract 2 from 10. So now we've got a new unit test we can run. So when we run it, our test passes, we expect 8, and when we actually call calculate with those numbers and send in a minus sign, we get 8 back. So let's see where we're at now. So our code coverage is going, what were we at, about 40%, I think, when we did add. We're over 50% now in our calculate method. So we've now covered the first 2 of our operators. Now, I talked about earlier how if we change something, unit tests will help identify if we've broken something, right? So we have all our unit tests passing right now, which is good. Let's say I go in here and I accidentally make a change. So in our subtract, right, this is the correct code. Take the current value, subtract whatever the new value is, and that's our updated current value. Let's say I just take that out by mistake. I'm mucking around, I hit the wrong key, or I'm changing something else. My calculator still compiles, right? I can still run my calculator. Now if I do 10 minus, whoops, sorry, if I do 10 minus 2, it actually gives me 2. Gives me the new value. So I don't get an error, but users are getting the wrong information, which is a real problem. An error would actually be better, because then users would say, hey, you broke something, this doesn't work. This is almost worse when we get no error, but people don't get the results they should get. Right? Imagine we're calculating pricing on a shopping website. Wrong amount. So this is where our unit tests help us. So I've broken something here. Let's go and run all the tests now. My unit test tells me we broke this. When we run it, we expected to get 8, but when we tried to do the 10 minus 2, we actually got 2 as our result. So every time we change something in here, we can go and rerun the unit tests and make sure that all of the tests that used to pass still pass. And if they don't, they actually will often tell us what's wrong. So this saves, as you guys said earlier in the class, saves a lot of time, saves a lot of money, and a lot of headache. that we can make new changes and we have to worry a lot less about breaking stuff that used to work, because the unit tests are going to point this stuff out for us. So I'll just put that back. So this is maybe the single biggest benefit to unit testing our code. Okay. So we've covered two scenarios. We've covered add and subtract. I'd like you guys to write the unit test, valid unit tests for multiply and divide. They follow the exact same format, change the operator, and change the assert statement. Use the same numbers. You can use 10 and 2. Keep it simple. So for multiply, obviously, you're going to expect 20. And for divide, you're going to expect a result of 5. So see if you can write the test. You can talk together. You can ask me for help. We'll review it together in a little bit. But see if you can get all your tests to pass. Question? Problem?
Yeah, if you don't mind just
Nope, no problem.
You're just missing a closing bracket. Actually, we wiped out a closing curly brace. These little lines are actually helpful, right? It's telling you there's a match for this up there. And notice there was a line there with nothing there. Yeah, you just have to accidentally wipe it. No. Any luck?
Yeah, one of you had to read it, so I missed the part on top.
Sure. When we're doing testing, we often have to simulate. We have to write all the steps of what a user would do, right? Because we don't have an actual user using our stuff. So we're simulating what they did to get to the point where we want to test it. That's what the arrange is. What are all the steps somebody would take if they were using our application to get to the point that we actually want to test this method? So we're imagining, our cases, they hit 10, they hit one of the operator buttons, and then they hit it 2 equals. So that's what our arranges do.
That's still just running along, Jonathan? The install still going? Yeah, probably take a while. Well, better it uses the school's internet connection than yours, right?
Oh.
You look done, Stuart? Yeah. Run.
And then you can that back because we do want our test to pass.
That's
So
about saying, so you probably change your code in Form 1 the same way I did, just to simulate a failure.
Yeah.
So you want to go back to calculate, right? So that's where it's helpful to say, yeah, we're still respecting 2, we're respecting 8. So that's where it's really helpful.
That's making a huge error. You have to go back and make those all over, or just call.
No, they stay. If you close the solution, the unit tests are stored in your file. So at any point, you just open the solution and click run unit tests.
Yeah, just, is this more common than?
Yeah, I just went through a
Well, in a
slide.
big
The credit
application,
card
you
stuff,
have both.
just use
You
that.
do this as you're developing,
And basically just
so that-
think for me. So-
that means there's far fewer, but by the time people test it, users test it, you're using the unit testing to have identified and allow you to fix most of the bugs. Right, so that means the process, when you put, by the time you put it in their hands,
No.
you're confident that the quality level is much higher.
Yeah,
than other bugs.
That's why I wasn't here.
That's a way to test it.
The way to test it, you want to test it yourself in an automated way. Because once you set these up, you can run them anytime.
Were these around for a long time? Like you were on it?
Yes, but I'll be honest with you, I haven't used these much. And I'm kicking myself for not, because this would save so much time and grief over the years and all the work I've done to have done this. And this is the first year that I've ever included that in any of my classes. But I've decided that it's something that, even if we don't do a deep dive into it, we don't do test-driven development where you write all the tests first, it's at least something you should know about and know that this is available for us and know how it works. Because it will save you tons of time and save your clients money to automate testing. In fact, Jarrett, who is the professor who's in here one before us, for some of his Java tests, that's how he marks them. He writes all the unit tests. You write a Java file and you submit your file to him. The way he marks it is, when I run all of your Java methods, does it pass all my unit tests? If it does, there's 100%, right? Your grade is equal to the percentage of the unit tests that pass. It's a really easy way for someone else to evaluate whether your code works the way it's supposed to. When I run it all, does it give me all the results I would expect?
So it's safer than literally testing it yourself.
Way safer. All right, Stuart, since you're done, you want to come and add, can you come and add your multiply method?
Do I have to type it? Or can I copy it?
Get it to work however you want to get it to work.
Yeah, pretty much. Yeah.
Awesome, you want to run them? Make sure they work. Here, you can just click run all on your test explorer. Yeah, run and leak. Thank you. So imagine the confidence that will give your boss or your client before when they say, what's the status of the application? Are we ready Are we ready to give this to our users for testing? Well, here, I pass 100% of our unit tests. And here's our code coverage. So we can also evaluate now. So here were Stewart's methods, which are great. So the setup was the same, except for the operator, right? We changed the operator. And in each assert statement, we change the result that we expect to get. 20 in the case of multiply, 5 in the case of a division. So where does this leave us in terms of our coverage? So our calculate method is almost completely covered now. 86% covered. So we still have this, which we could check for. We also haven't checked what happens if we have no operator. They just hit the equal sign. That. There's still one scenario, though, we probably should also test for. I'll just run my calculator again. And that's this one, right? 10 divided by 0. So this is one of the possibilities that we should also be unit testing for. Because we don't want, and then that unit test should identify a way for us to modify our calculator so that users don't break it. So what should happen in this scenario? If a user actually tries to divide by 0, what happens? I mean, try it out. Grab your phone, you have a calculator app. What does it say? If you do 10 divided by 0, what happens? Is that okay? Or I'll try it on my Windows calculator. You get an error. Okay, so here's my little Windows calculator. 10 divide by 0. So how should we handle this? So we could put in a message. We could put in.
So I was going to ask you, don't do like a statement like if.
Yeah. Yeah, we're going to need one. Absolutely. Because right now, if they hit divide and equals, it just runs, it divides regardless of what's in there, right? So what we're going to need to do, absolutely, Brandon, is write an if statement here. Rather than just automatically divide, we're going to need to check. If the new value is 0 and the operator is divide, we're going to have to show an error so that they don't crash the program. Right now, the whole thing just breaks. So we've been writing our code and then the unit test to test it. Let's actually write the unit test first, and then that'll help us figure out what that if statement needs to look like. Do a mini test-driven development. We'll write one test for one scenario and then write the code after to make sure that test passes. Okay. So we already have a divide valid. We'll say divide by 0 invalid. And again, we're just using the same structure, arrange, act, and assert. So we'll start out with 10. That's our first number. This time, instead of a 2, our second number is going to be 0. And our operator, again, is divide. So they type the 10, they hit divide, they hit 0, then they hit equals. That's what we're simulating, what I just demonstrated with the app where I crashed it. Then we call calculate and we pass in the second number, which is 0. So in this case, maybe the easy thing. So Melissa, I think you said, what did it show you on your app? It shows the word error in the display. Okay. That's what we're going to assert. That's what we're going to check. So assert dot r equal. So in this case, we're not checking the total. We're not going to be able to calculate a total. What should happen when we call this is the display should be changed to the word error. That's what we expect should happen if the user tries to divide some number by 0. If we run this test right now, is it going to pass or is it going to fail? Right. Well, let's try it. So right now, this test fails. So we are expecting to see the word error on our button. But our calculate code throws this error, divide by 0 exception, and stops running. So now we can go back to our calculate method and we're going to do exactly what Brandon said. We need to check for this scenario before we try and divide. And once we do that, our unit test, we can run it again and our unit test should pass. So in here, well, I'd kind of done it already, but I'll just take this out and we'll write the code. So we'll say if our new value is 0, so we are only going to try to divide if the second number isn't 0. In this case, second number is not 0, so we can divide. So this should accomplish two things. This should make our unit test pass. It should also prevent our calculator from crashing when someone's using it if they try and divide by 0. So we'll run the unit test again. It now passes. If we pass in a 0 as the second number, we get error just coming to and being displayed. When we try it this way, it shouldn't crash anymore. Okay. What happened? So it didn't crash. We need to go look at our divide. Oh, I know what happens. Here's what happens. We're setting it to error, but then the equals button sets it back to the current total. And think for a minute. So we need to do one more thing to fix this. So we no longer get an error, but if I do 10 divided by 0, just shows me 10. It doesn't actually tell me I got an error, but a real calculator does. It should show us. So what's happening here is we're displaying error, but then the equals overwrites it and puts back our initial number. So we're going to change one more thing in our equals. We'll say if it says error, don't wipe it out. Only show the current total when we have no errors. Not equal to. Actually, hold on. I have to think whether this is a good idea. So that means, yeah, not equals. Try that, see if that solves our problem. So this was in our btn equals click method. I'm going to try it and see if it works. So we do 10 plus 2 equals, we get 12, and minus 2 equals, we get 8, 20. Okay, so we haven't broken anything yet. And now if we do 10 divided by 0, it says error, which is good. So we can't really do anything else. We now need to basically clear it and start again. So now users can't crash our program by dividing by 0 because we've anticipated that somebody could try to do this. And we're checking and making sure we give them an appropriate response even when they do something we don't want them to do.
So for the test method for dividing by 0,
Yep.
you had a certain argument.
No, we're asserting that the display, the text of the display button is equal to the string error.
So my assert our equal.
So all our tests pass. We'll see. I don't know if that's changed our code coverage at all, really. But we're pretty good. I think we're at over 80% anyway. Yep, so we're up to 89% now in our calculate method. So we can write one more little test for this, and we'll call it a day. So what happens if we only have one number? So let's say the user types 10 and then just hits the equal sign. We have nothing to calculate at this point. So we want to make sure that our total is just set to 10. And if we run our calculator this way, 10 and equals, we shouldn't try to do any calculation at this point. or even if we hit 10 and plus, we just want to make sure that those values are so we want to check this section here that's red. First input valid total. We want to make sure that's declared as a test method. This arrange is going to be a little different because we only have one number. We're not passing in two numbers, and we're not passing in any operator. We'll actually need 2 unit tests for this to do it properly. In this case, our first input is going to be true. What happens when we only have one number and calculate gets called? It's our first number and it's 10. So we expect total is going to be equal to 10. So we haven't performed any math yet. We just want to make sure that that first number is stored correctly. That's what's happening right here. If our first input is true, then that's our initial total, our first total. And then the other variable we want to check when this happens is once we've got a number in our total, we need to change first input from true to false. We've already got one number, so the next number we can do math if we get another one. So we'll write one more test. We'll check our coverage and we'll be done. First input becomes false. We'll start out with no numbers entered. The users just open the calculator or hit clear. Type in 10. We expect that our first input variable, which started out as true, is now false now that we have one number kind of in memory. And we're waiting for an operator and a second number to do a calculation.
I might have missed it. Would you mind just explaining why you have the form first and true instead of false?
Okay, because by default, when our form loads, we initialize it to true, meaning the next number. So when the form when someone runs the calculator for the first time, and types in a number, we need to know if there are any previous numbers that they've entered. So if I type 10 and plus, what should happen when I hit the plus symbol? Can I do any addition yet? Right, but we need to know that we have to remember the 10, right? Because when I hit plus, a calculator, it removes it from the display,
Okay, I see.
right?
Okay, yeah.
So we need to know when somebody enters a number, is this the first number that we just have to remember and kind of hold and wait for the second one? Or do we already have a number and now this new one is the second one and now we can actually add them together, right? So if I hit 10 again, it knows I can actually do the math, right? So our calculator behaves differently when someone enters the first number versus entering more numbers afterwards. So that's what so by default, we're setting that value to true. When you first start the calculator, hit clear, the first number entered, we need to know that's number one, don't calculate yet. So that's what we're checking for. So in our calculate method, the very first thing we do is say, if it's our first number being input, just store that as the total. And then we change first input to false, so the next number we can do math with.
Is that weird?
Yeah, so this section in red, that's what we're unit testing. It's saying you've got this code here, but you never actually checked whether this code runs properly. So we're writing two tests. The first one is when we do set first input to true and pass in a number, that number becomes our total, right? So our total changes from 0 to 10 or 0 to 100. The second unit test then checks that we're changing our value from first input so that we know we're now on number 2, 3, 4. So that's what those two tests are designed to do. And they do both pass.
So in that case, the way that.
That's right. We're not concerned about any other numbers. We just want to know what happens when they put in the first number. Well, that's right. So 10 plus 10 plus. Yeah, it does.
Just went 10 plus 10 plus 10.
I don't think I wrote it that way. I probably could have. Most calculators would. Let's see. Oh, yeah, I did do it that way. So it did remember, right? I did 10 3 times.
Because of the way you.
Because I know if I'm not on the first input, it means, yeah, keep adding. If we're on the first one, it means store this number and wait for more. Then after that, you can add as many numbers together as you want. So if we check our coverage here, we should be closer to 100% now. Well, this is our last check. Let's see where we got to. So pretty good, right? When we first started this, we were at 0. And we've now successfully unit tested. You know, we had to write 8 unit tests, but we've covered 94% plus of the logic in here. The only thing we didn't cover was what if there's no operator, if they just hit the equal sign. I mean, nothing happens in the program, it doesn't break. We didn't write a unit test for that. So to get to 100%, that would be the only other unit test, is what happens when we call calculate with no operator. Well, nothing. We just keep the total where it is. We don't do anything. So that would be the only other. So it says here, 18 blocks covered, and that scenario is the only one that isn't covered. So we could do one more unit test. I don't think we're going to write it, but that's how we would do it. Okay. So I'm going to stop this stream. I will put all of this, I will put this solution up on GitHub. Okay. So I'll probably just publish it to, I'll make a new repository and maybe mark that it's the completed code with unit tests so you can have to refer to. So please make sure for next week's class, I will send out an announcement to remind you. If you can go into the forum And try to give me a specific question or concept that we can review. Don't say like all of lesson 4, because I can't redo all of lesson 4 next week. Things that don't make sense or a refresher would be good on, we'll do that next week, and we'll compile some study notes which you can bring with you to the final test. Okay? And remember, your assignment 2 is due next Thursday night before class. Okay, that's all. Hope you guys have a great weekend.